Alright guys, another way to look at vectors is what we call a linear combination. That is where it looks like this. V, the vector, would be AI plus BJ. This is your horizontal component, and this is your vertical. So, for example, 2i minus 3j is the same as 2 negative 3 in component form. Okay? So then we sometimes like to use what's called a unit vector. A unit vector is a vector that has a magnitude of 1, meaning the length is 1. The way we make any vector become a unit vector is by the following. U would be your vector divided by its magnitude, or you can say 1 over the magnitude times the vector. Either way. So let's do an example of this. You can kind of see. If V is negative 3, 2, this obviously does not have a length of 1, so we want to figure out what unit vector, given these components, would have a length of 1. So the first thing to do is find your magnitude. That would be the square root of 9 plus 4, or 13. And then either divide each component by it or multiply by 1 over that magnitude. So that would be negative 3 over the square root of 13, comma, 2 over the square root of 13. And as usual, sometimes your book will rationalize this and sometimes it will not. I am okay with either one. If you were to rationalize this, it would be negative 3 square roots of 13 over 13, comma 2 square roots of 13 over 13 in component form. Now, let's let you try one. You try u being 4, negative 3. Pause the video and try and find the unit vector for 4, negative 3. When you are finished, unpause the video and check your answer. So, let's see if you are correct. The magnitude of u would be the square root of 16 plus 9, which is 5. So this unit vector is 4 over 5, comma, negative 3 over 5. Next, if a vector has a direction, then it's going to have a direction angle, which means theta is going to exist. And remember, theta always starts at the positive axis. We can write V as magnitude times the cosine of theta, with theta being your direction angle, comma, the magnitude sine of theta. Now, we're using cosine because that correlates with our x, sine because it correlates with our y, and then we multiply it by the length of our vector. So let's see what we can do with finding components. If this theta is not a special right angle, then you would have a calculator. If it is one of our special angles from 4 and 5, then you would have to do this by hand without a calculator. So as always, there will be a calculator active and calculator inactive section on the quiz and test, so be prepared. So let's look at the first one. If my theta is 115 and the magnitude is 6, it's quite simple. All you have to do is plug in your formula, 6 times the cosine of theta, 6 times the sine of theta, which would be 6 cosine of 115, 6 sine of 115, and type it in the calculator, because 115 is not a special angle. That would give us negative 2.54 and 5.44. So this is in Q2, obviously, because the direction angle is 115, and that is in quadrant 2, and our ordered pair correlates with that. Now, what if you are required to find the magnitude and direction angle? If I already give you the vector, can you work backwards? Meaning, if you are told U is 3, 2, can you tell me what the magnitude is and theta? Magnitude, pretty simple. 9 plus 4, square root of 13. Then to find theta, we have to use the fact that our vector is 3, 2. It's going to equal the square root of 13 cosine theta, square root of 13 sine theta. Now, theta is the same for both of these, no matter what. So we can use either sine or cosine. You need to be careful making sure that you are in the right quadrant with these angles, because remember, to find an angle, we're using the inverse, and you know sometimes that gets a little tricky. So for this one, we are in Q1. So I'm just going to say 3 equals the x component. So that equals the square root of 13 cosine of theta. So 3 over the square root of 13 is the cosine of theta, which means theta is the cosine inverse of 3 over the square root of 13, which is 33.69. That angle fits our problem, so it is correct. If it doesn't fit the problem, then you need to figure out, one, what you did wrong, or you might have to add or subtract 180 to get it back into the right quadrant. So think about just where it should be. So let's let you try this one. V is -2, -5. Find the magnitude and the direction angle. Pause the video to make sure you know how to do this, then unpause it and check your answer. So here you can say -2 equals the square root of 29, which is your magnitude, cosine of theta, or you could use -5 is the square root of 29 sine theta. Either way, theta is 248.2 degrees. The last thing in this section is the idea of velocity. Now, velocity of a moving object is a vector because velocity has both a magnitude and direction. Okay, what's the magnitude, you may ask? Well, the magnitude of velocity is the speed. So when you're given some of these word problems, the speed at which something is traveling is the magnitude. So what we're going to do now is look at example 7 on page 461. It says a DC-10 jet aircraft is flying on a bearing, everyone's favorite problem, of 65 degrees at 500 miles per hour. Find the component form of the velocity of the airplane. Recall that a bearing angle is the angle that the line travels due north measured clockwise. If you need to go back to section 4.1 or 4.2, it's explained in more detail. Also, if you look over to the left, the picture has been drawn for you, but we're going to redraw it just so you can kind of know what's going on. So you got a little airplane, a DC-10 jet flying this way. It's 65 degrees bearing, so it means this is 65 degrees, which means my angle down here is 25 degrees. And remember, that's going to be our theta because it's from the positive x-axis. It says we're moving at 500 miles per hour, so that, remember, is our magnitude. So then all we have to do is plug into our formula to find our vector. U is going to be 500 cosine of 25, 500 sine of 25, which is 4, 5, 3, 15, 2, 11, 31. Okay, so again, speed is your magnitude and use that bearing angle. Next, example 8 talks about a pilot's flight plan leaving San Francisco International Airport and flying 727 due east. So we are flying due east, right? That general direction. There's a 65-mile-an-hour wind with a bearing of 60 degrees. So here is our 60-mile-an-hour wind at a 65-mile-an-hour wind, Got a little backwards there. At a 60-degree angle, right? Then it says find the compass heading that she should follow and determine what the airplane's ground speed will be, assuming that its speed with no wind was 450 miles per hour. So the first thing we have to do is figure out what the vector is, and then we are going to add the airplane alone. And the airplane alone is this way with 450 miles per hour, and we don't know what that angle is. Okay, so the first vector we will find is, okay, you know what? I don't like this problem. Ignore it. You do, however, need to know the basic ones with speed because that has been on the exam. So make sure you can do if an aeroplane or anything is flying at a certain miles per hour with a basic bearing angle, can you plug it in component form? Remember, be able to do the special right angles with these problems. For example, if I say the cosine of 30, the sine of 30, you should know which one is 1/2 and the square root of 3/2 and be able to do that basic math computation without a calculator. Now for this section, you should look at problems starting on page 464 and 465. The problems that you really should know how to do are 1 through 42. Remember, the odd problems have answers in the back of the book. I have my book with me, so I have the even answers and can answer any questions that you have. Feel free to text me. This is the end of video 2 for section 6.1. Please click on the video for section 6.2. You're required to know both and feel comfortable with both on Monday when I get back.